Assalamualaikum warahmatullahi wabarakatuh. My name is Naswa Akil bin Abdul Rahim. My student ID is 2021143579. I'm from class EMD2 M1B. I'm student of Bachelor of Mechanical Engineering at UiTM Shah Alam. Today I would like to make a video for my assignment for subject MEC451 Thermodynamics. In this video, I will guide you how to answer the question step by step. So this is the question given. Refrigerant 134A at 800 kPa and 25 degrees Celsius is throttled to a temperature of negative 20 degrees Celsius. Determine the pressure and the internal energy of the refrigerant at the final state. So, the question need us to find first the pressure at final state or P2. Second, the internal energy at final state or U2. So, from the question given, we can get the data from the question. So, the data. Firstly, the substance used is refrigerant 134A. Second, the initial pressure or P1 is equal to 800 kPa. Third, the initial temperature or T1 is 25 degrees Celsius. Next, the words for throttle is, we can assume the enthalpy at final state is equal with enthalpy at initial state, which is H2 equal to H1. Lastly, the final temperature or T2 is equal to negative 20 degrees Celsius. So, for the step 1, we must check the properties of refrigerator 134A using table properties. So this is the properties table. The question said that the refrigerant 134A is at 25 degrees Celsius, but the properties table did not have 25 degrees Celsius. So how do we tackle this problem? Firstly, we must use the interpolation method. How do we do the interpolation method? Firstly, we take the properties from two temperature, which is 24 degrees Celsius and 26 degrees Celsius, because between 24 and 26 is 25 degrees Celsius. Next, we make a table. In this table, we include the temperature, which is T, the internal energy for the saturated liquid, UF, and the enthalpy at saturated liquid, HF. The next step is how to find the UF1. So this is the equation. How do we can get the UF1? The left hand side is for the internal energy and the right hand side is for the temperature. This is the one after I simplify it. So the answer for UF1 is 85.85 kilojoule per kilogram. Next is we must find the enthalpy for HF1. Same with the previous, the left hand side is for the enthalpy and the right hand side is for the temperature. So after I simplify it, I get this equation. So the answer for HF1 is equal to 86.405 kilojoule per kilogram. So we move on to the second step. So for the second step is we must sketch PV diagram. So this is my PV diagram that I had sketched. So firstly, we must sketch PV diagram and the saturated line. This is the saturated line. Next, we must sketch line for initial state. So for the initial state, the P1 is equal to 800 kilopascal. So this is the line for the initial state, and the initial temperature is T1 is equal to 25 degrees Celsius. Next, we must sketch a line for the final state. So this is my final state, and the final temperature is T2 equal to negative 20 degrees Celsius. And this line, we can see that why I make this S1 equal to S2 is because the words from the throttle. So the throttle means that H1 is equal to H2. We assume it. And next, we must find the enthalpy. So this is enthalpy that we need to find. How do I find this value? To find the Hg1 value, same with the previous, we use interpolation method. We must take between 2 degrees Celsius, which is 24 degrees Celsius and 26 degrees Celsius, and this is the enthalpy for the 24 and 26 degrees Celsius for the Hg. Same with the previous, the left hand side is for the enthalpy and the right hand side is for the temperature. After I simplify, I get this equation, and the answer I get for the Hg1 is 264.175 kilojoule per kilogram. So the Hg1 I had found. The next, how do I found HF2 and Hg2? This is very simple because we just take the value from the property table. So the final state is the temperature is at negative 20 degrees Celsius. So this is the HF2 value, which is 25.49 kilojoule per kilogram, and this is for the Hg2, which is 238.41 kilojoule per kilogram. That's how I found the value for the HF and Hg for the 2 points. Lastly, we go to the solution. So for the solution 1, we must find the pressure at final state, which is P2. The solution is, it is very simple. The P2 is equal to P saturation at negative 20 degrees Celsius. We take the value from the property table. So this is the property table. So the temperature is negative 20 degree, and the saturation pressure or Psat is equal with 132.82 kilopascal, and this is the answer. Next, we go to the second question, the internal energy at final state for U2. So this is the solution. Firstly, we must find X. So this is the equation that we will use. So H2 equal to HF2 plus X in bracket HFG2. So firstly, we must find the X. 86.405 equal to 25.49 plus X in the bracket 212.91. Why do I choose this value? This is because remember that the word throttle, which is H1, we assume it equal to the H2. So the H2 is equal to the H1. So this is the value that we can use. So after I calculate it, I got the X is equal to 0.2861. Next, we find the U2. Same method that we used from the equation previous, but we just manipulate it from enthalpy to internal energy. The equation is U2 equal to UF2 plus X in bracket UFG2. So we must find the U2. So the UF2 we got before this is 25.39 plus the X value that we've just calculated plus 0.2861 in bracket 193.45. The internal energy for the final state that I get is 80.7 kilojoule per kilogram. That's all from me. Thank you for listening and Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.